Well, welcome to Tim's Take, and we have two special guests today. We have Dr. Tony Lupo, who's familiar to many of us from the Atmospheric Science Department. He's a professor there, and he works with the El Niños and the blocking highs and all these things that affect our weather. You had a good term for that. What was that, Tony?
That was, I call it large-scale dynamics.
Large-scale dynamics, all right.
Yep.
But then we have a new person. You just started August 1st.
Correct.
Dr. Zachary Leeser, and you are director of the Missouri Climate Center.
Yes.
And also work with the Mesonet that so many of us are familiar with. That's how we get our daily data on the weather.
Yes, and we're proud to provide that data, and I'm excited to be here and start this new role. So thanks for having me today.
Well, you're welcome. And Tony, you were the interim there for a while Pat Gannan, after he retired and Zachary came on.
Yes, I was, and boy, is that hard. State climatologist by itself is hard, never mind trying to do two jobs.
Well, we're going to not only talk about weather, and also we'll give a forecast at the end, right?
Absolutely. I have something ready. So.
All right. Well, this summer has been kind of a topsy-turvy summer. What's happened? I thought we were going to have an El Nino all year.
Well, you don't have El Nino all year. The year started out with the dying La Nina, and it took a little bit of time to wash out. It was probably by about March, April that it really washed out. And, of course, now we're seeing signs that El Nino is finally coming in and settling in, and that's having an impact on our jet stream. Typically, when a La Nina dies, we typically have a warmer summer, but when an El Nino comes on, we have a cooler summer. So we kind of had those two things that tend to give opposite signals for Missouri. And this year, summer's been pretty close to normal here, but hot elsewhere.
So before we go too much further, can you explain what La Nina and El Nino are?
Absolutely, absolutely. La Nina and El Nino are an irregular warming or cooling that happens in the tropical Pacific Ocean region. And this warming or cooling will happen every 2 to 7 years. And because you're changing the distribution of heat on the oceans, that has an impact on the jet stream, especially for North America, which is right in the path or right downstream of these two phenomena.
So off the coast of South America, West Coast.
Yeah, the west coast of South America and Central America, Mexico, that whole area, you'll see warming waters begin to emerge. Occasionally what you'll see is that warm signal be stronger near the date line, and that's what we call El Nino Modoki. and a Modoki is a Japanese word that means the same thing, only different.
Oh. And El Nino it means because it happens around Christmas often.
Yes, it generally peaks in December, which is the peak growing season down in South America and those areas. But the reason they gave it that name is because it peaked in December. And the Spanish, when they colonized that area, gave it the term El Nino, meaning the boy, which referred to Christmas.
So you mean in the 1500s they noticed this?
Oh, absolutely. The indigenous people of South America were the ones who described it to the Spanish, and they knew about it for eons before. So.
Oh, my God. So they knew every 2 to 7 years they're going to get this weather pattern.
Yes, they would get this irregular change that would upset their growing seasons.
Wow. And that was a warmer. Now, La Nina is cooler.
Yes,
water.
La Nina's on the other side of that. That's cooling. Mm-hmm. And we kind of think of it as an irregular cycle, so that you can go from El Nino and then to neutral, then to La Nina, and then back again. But sometimes you go directly from one to the other, or like we saw from 2020 to 2022, we just had 3 years of La Nina in a row. It just kind of wouldn't go away.
And that typically gives us what here in the Midwest or North America? La Nina.
Yeah, La Nina typically gives us a cooler winter here that I've noticed in our studies, because what you tend to get is a lot of warmer conditions out west, and that allows the cooler air, or that results in the cooler air being more in the east. With El Nino, you tend to get either a jet stream that's strong across the south, which means a warmer winter for northern states, or with this Modoki, you get a signal that's similar to La Nina. And so that's what makes Missouri winters so very difficult to forecast, is we kind of sit in between a lot of the stronger signals that these two, El Nino and La Nina, impart on the USA. So a lot of it'll depend on how that signal emerges as to how warm or cool will be.
And often, I think you alluded to this earlier, is that the transition from La Nina to El Nino is when we have some of our drier weather, our droughts and such.
Yeah, La Nina tends to be associated with drought. We had 3 straight years of La Nina from 54 to 56, and those were some very powerfully dry summers. The same thing happened again from 73 to 75, and that resulted in some strong droughts then. The only difference being that the temperatures with the 1970s event were cooler than the 1950s events. The 50s combined the heat and the dry. The 70s combined, you just had the strong drought.
It happened in the 30s. We always think about 34 and 36 as being very hot, dry.
Yeah, that was a very strange period, because we had an El Nino in 1929. We had an El Nino in 1940, but we had neither through the 30s.
So we were kind of in neutral.
We were kind of in neutral, but cool neutral, which was closer to La Nina. And I think that's why we got some of those very hot summers. I think that's at least part of it. So.
Wow. So the long-term predictions with all of these things going on, that really throws a lot of wrenches into it.
Yeah, because the stronger signals that these things give to North America are usually found in the southern states or the northern states. And of course, the way the jet stream is across the United States, you either have a trough in the west and a ridge in the east, or vice versa. And where does that put Missouri? Right smack in the middle of things. And so forecasting where these features are going to set up takes some good guessing.
and do I understand it right? Along the jet stream is where we get a lot of our thunderstorms firing up in the summertime?
Absolutely. And that's what we've seen this last week or two. We've had a very strong jet stream out of the Pacific region across the Northwest, and we've actually got right now northwest flow over the United States, which is a little unusual for summer, but it's basically the border between that heat dome that's been in the south and the cooler than normal conditions in the northeast. So
yeah, I know where we're getting some nice cool weather, they're still getting bad in the southwest.
Oh, absolutely. They've had some record heat in terms of the persistence of it, and Texas is still sweltering. So
and we got lucky that we just saw a little bit of that before the jet stream.
Yeah. That heat dome kind of poked into Missouri there at the end of July, and I'm glad it didn't stay. I just don't like the heat.
No, I like warmth, but heat's a little different. Now, Zach, what are you going to be doing? If Tony's doing all these, working with all this on these phenomena that are happening, what will you be doing as director of all of this?
Well, that's a good question. And as a state climatologist, there's a lot of extension throughout the state and a lot of folks that are wanting to know more about the climate. And one thing we've seen is they're very interested in climate hazards. And what we've seen transitioning from La Nina to El Nino is a drought that's occurred this summer. And so that's really been keeping me busy. There's a lot of folks statewide that are working and thinking about how to mitigate drought and have questions about drought. Mm-hmm. So currently that's taken up quite a bit of my time, especially at the end of the growing season, thinking about this drought.
So you have to take a lot of what Tony and the other faculty are doing and kind of synthesize that to somewhat figure out what farmers and other people should expect.
Yes, absolutely. And so, it's really a team effort, and being able to have this kind of expertise and then communicate it and relay it out to the state as well.
And part of your duties is part of that you have the Mesonet.
Correct. Yeah, so we've got approximately 40 stations statewide, really ranging all the way down from the Boot Heel up to Northwest Missouri. And those have provided a lot of utility this summer, and really getting local scale rainfall amounts, getting that information for most locations in near real time, as well as tracking things like the heat as well when we had that in late July. So that information's critical, and I think in terms of drought, a lot of views and a lot of use out of that information.
And does that help you all with your forecast then, as you get all this data from all over the state that's happening?
Yes, I think it helps forecasts a lot. These stations provide high quality data. They're maintained well. The sensors are maintained and calibrated, so you can really trust the record at these locations. And they've also been operating for a long enough time that we have a good historical period of record or climatology at that location. And so when you have those stations, that's really valuable to see the historical context. And so I think broadcast meteorologists and those working at the National Weather Service also use this information as well.
Now, are there other weather stations in Missouri also that like NASA or the National Weather uses?
Yes, that's a good question. And there's quite a few different kinds of weather stations. The National Weather Service maintains several. There's also several that are maintained in conjunction with voluntary weather observers, so called cooperative weather observers across the state. And then a few other federal climate monitoring networks have stations here. So when we put all that together, we can get a good look and hopefully fill in most of the holes around the state of where we can get those good observations.
And then that helps you with your future weather forecast that these citizen observations too. So how much rainfall that I got or snow or what have you.
Absolutely. We can kind of look and for example, with the rainfall event, verify, how did the forecast look compared to what we saw, especially at a really fine scale. But weather models also kind of pull in all these observations in real time and help to kind of spin up their model and make those predictions as well.
Well, now, I used to have a rain gauge that Pat, it was your predecessor, and I would, when I got a rain, I'd always go online and report that. Then a hailstorm broke it, cracked it, so it started leaking, so I can't use it anymore. What is that called? And can other people get to be part of that?
Correct. So that's referred to as the COCORAS network.
Okay.
So it's going to be the Community Collaborative Rain and Hail and Snow Network. And so it's all volunteer observations of these variables. And so anybody can be a volunteer observer. We could probably get you a new rain gauge to replace your cracked one.
Okay, I'd like that.
And those are vital observations. A lot are, weather hobbyists or interested in the weather and are really great about giving their observations every day, even dry days. And that's really good information that you can pop open a map every morning on their website and see that.
Because I've noticed this, we've had this week-long plus of rainfall. I'm at like 2.85 inches at my house. Down the road, some people have 4.5 already, so it's variable a lot.
Yes, and we see that a lot during the summertime when a lot of this precipitation is convective or thunderstorms. So very localized rainfall. Some locations will get a lot, and it might even miss some locations. So that's where if you can get talking sub-county scale, seeing what your neighbors are seeing, that really helps with those observations.
Sure. Now, so Tony, do you think we have now moved away from La Nina and full-fledged getting into El Nino? So the hot weather's over?
I think we have. I think that it was a very slow process, and it seemed like that signal just didn't lock in really till about the end of July. So I think that the next month will be fairly close to normal, maybe even above normal with precipitation, and that August will be close to normal, which has been the character of this whole summer. But we might be in for a little bit of a cool fall, and then it'll switch over, I think, to a warmer winter.
So our winter's not going to be a brutal winter then?
I don't think so, because if you look at the way El Nino is setting up, it's setting up like two other classic El Ninos in recent years, 1997 and 2015. Okay. And in both of those cases, you had the type of El Nino that I described earlier, with the sea surface temperatures warming closer to the continental land masses. And that's called, well, I call it El Nino Classic, because it's kind of the first type of El Nino people recognized. And being a Coke drinker,
I thought the exact same thing.
Liken it to Coke Classic.
All right. But often your forecast, that can be happening, and then you may get like a blocking high somewhere that just totally changes everything.
Well, absolutely, and you're veering into a great topic about long-range forecasting, is that when you're doing a long-range forecast, you're generally doing it for an aggregate of time. And so there's many ways that forecast can be wrong or right. For example, we had forecast a pretty harsh winter back in 2013, 2014. December was 6 degrees above normal. January was 2 degrees above normal, but February was 10 degrees below normal. And when you look at the statistics, it verifies our forecast, even though 2/3 of the time it was really warmer than normal. So, and that's the thing. What we can't predict is how that's going to come about. Because if I say it's going to be above normal, it could be a degree above normal every day, or you can have 15 degrees above normal for a time and 10 degrees below for a time, and it'll still work out to be a good forecast. So
right, just like this summer, you knew El Nino was going to set in. It's just when.
Yeah, and I was looking over my long-range forecast from this spring, and I think it's going to verify pretty good, even though we had a rough start to the summer season.
So how long will El Nino last then?
Generally, these things last about 12 to 18 months. So it'll come and it'll get through the winter, and then by this time next year, we may be talking about something else. Occasionally, you get 2 years in a row to be El Nino, but that's more unusual than La Nina.
So we could probably say right now, then, this spring and next spring of 2024 in summer, or at least the first part of summer, will be fairly wet or moist.
Could be. It depends on how long this pattern sticks around.
Sure. So. And that's just that's the science in it. They're trying to figure out why.
Oh yeah, and a lot of long range forecasting is not only looking at the dynamics of the atmosphere, but just going back into the history and the statistics and looking at years that had a similar look to them, which we call analog forecasting. You look at something that says, oh, that was similar to this year, to a particular year, so maybe it'll evolve the same way that it did at that time.
I do that myself. I remember many of the crop years that I've been associated with, and I'll think, well, this winter and spring remind me of 85.
Absolutely.
And we had a very good year, and often that continues.
And that's where experience comes in as a forecaster. And of course, I tell students that forecasting is not only science, but it's part art.
Yeah. There's another personal experience. The fall of 1979, my dad purchased a center pivot. And I remember going in there, it was by October of 79 to go. My dad went in to pay for it, and the person there said, have we ever had such a beautiful fall to get our crops out?
Yes.
Well, what 80 was like then.
Oh, yeah.
we paid for that center pivot in 80. It's terrible drought. And then I've noticed that when we have beautiful falls to get our crops out, we pay for it the next summer, often with droughts.
Absolutely, and that's that back and forth between El Nino, La Nina, and neutral, and all of that. And of course, humans, of course, we live a limited amount of time, and some of these AI techniques, these statistical techniques, try to mimic what we as humans do when we take experience into account. And the computers are trying to do that now in a statistical way. And of course, if we can perfect that technology, that would be a very big help to long-range forecasting.
All right. Yeah, we think of weather and climate are two different things.
Oh, absolutely, absolutely, and that's where Zach is going to be coming in to his own when he gets started on the job here, because we'll be looking to him for climate expertise. So.